So what I would like to do today is take this opportunity to give you guys a little more information about movement and how the bones in the Quamerticus sphaera facilitate the way that they move. And I hope that you guys got a chance to see the drawings of the full model. And just to give you some orientation points, this is the main body, the skeletal structure of the main body, and the cephalic horn is in front of this here. And then the tail comes off of this side, just to kind of give you an idea of what you're looking at. The way this is set up, we'll talk about the front first. This is the skull and the first vertebrae. And the part of the nervous system that goes through here is you know, you obviously want to protect that so that, you know, if anything happens to that, they're not going to be able to move and they could possibly die, obviously. So their cephalic horn is a ramming weapon. And so in order for them to be able to protect the brain, which is right behind that, they need a lot of structure and they don't want this to bend too much this way. So if you look at the way that these two connect, is that these occipital condyles here are nice and big, and then the structures that connect to them are really wide, so that, you know, they have a lot of movement this way, but not a lot of movement this way. And that's going to protect, you know, so that, and there's a lot of padding here, as you can see, like this is going to allow a lot of movement back and forth this way, so that, you know, things aren't kind of squished in this way and nothing will happen to the brain. So if you want to pass those around, you guys can kind of play with those and see how that works. And one of the most interesting things that I have found about this creature is that they have a partial endoskeleton, which is this, and they have a partial exoskeleton, which is kind of like a crab, which is the underpart of where they are. And that's what kind of their weight is spread out on, and it goes into the legs and also into the arms, which kind of creates their movement in those areas. And it's mostly just on the ventral side in the front, and then as the creature, as you move back to the back this way, it kind of comes up the side. So you can see the ribs get shorter here, and that's because the exoskeleton starts to move up the side of the form here. And then they have plates on their bellies so that when they're moving side to side, that will allow for that movement. So obviously, when these things are moving, since there's not a lot of side-to-side movement on the head side, the middle portion, their thoracic and then their lumbar vertebrae are going to facilitate more side-to-side movement so that they can actually move through their environment this way. So if you look at some of these are the first and the second lumbar vertebrae here, and if you look at those in comparison to some of the ones here, this articular facet is going to point up this way to allow for movement that's kind of up like this. Does that make sense? Whereas here in the back, you can see that they're pointed out more toward the side, and that's going to allow for the tail portion to really swing back and forth. And then there are a lot of tendons and ligaments and their muscular system allows for that movement as well, and you can pass those around and play with those. Okay, we all straight so far? Okay, good. Are there any questions that we have about their movement? No?
This is a male, right?
The skeletal structure that I have here is more or less ambiguous for the sex. The females do have tailbones. They have, if you notice the wide teardrop tail, they have floating bones at the end of each of those three segments that kind of help to support that structure. So, but the rest of it is roughly the same. So if you look at the human skeleton, it's for the most part, it's very similar as well in both males and females. There's some variance in the hips and then the size of the bones and things like that. So that's really interesting. Let's see, what else can we talk about?
So you mentioned moving through the landscape in this kind of S-curve way. What kind of landscape do they live in?
You wouldn't believe me if I told you.
Really?
Well, it's kind of a rough area to get into because I have to leave the facade of being a scientist to talk about that. It's an area that I purposefully don't like to talk about because I think that the most important thing in my artwork is for the viewer to imagine, to use their imagination. And if I put this in a very specific place, then that defines it in such a way that each viewer is going to say, okay, this is where it lives and this is what it looks like. And what's really exciting to me and what has always been exciting in my work is when people say, oh, you know, how big is this thing? If it's this size, then it could be in a certain landscape. But what if it's a microorganism and it lives inside your body? Then it could be completely different. What if it lives, you know, on another planet? What if these things are gigantic and it's like, you know, the size of this whole room? You know, it could be something completely different. So I like to kind of give hints at what their landscape is without being too particular.
What hints?
What, sorry?
What hints can you give us?
What hints can I give you? Well, these creatures are vegetarian, and they feed on a lot of grasses. Their mouth is actually, the arms come out here, and then out of the ventral side of it is the opening for the mouth, and it kind of unfurls, sort of like a snail does, and it kind of crawls along. So it's the vegetation that they eat is kind of low-lying, like grasslands, things like that. And the females build structures with their tails. They use them kind of as shovels to make these little kind of like caves almost with the mud, so that they can hide from, you know, predators that might come in, or from, you know, any kind of crazy weather that they have. So that will kind of give you a little bit of advice there. Mm-hmm.
So Dr. Sesler,
Yes.
can you, talking about locating it, where would you locate this on the tree of life, I guess, in the, you know, the sort of evolutionary tree? What branch does it come out? Is it related to?
If we think about obviously, you know, the only thing that we know is what we've studied and what exists on this earth. So it's kind of a combination between a vertebrate and an invertebrate, like I was saying. So it's kind of, it exists somewhere, maybe like a hidden or like a missing link between the vertebrates and the invertebrates, because, and that is not only with their bone structure, but with their respiratory system. There are a lot of ways that they kind of both exist. It's kind of like a bridge between those two gaps, between the way those two types of creatures function. Any other questions?
I'm just amazed that the size is up in the air, because I've been convinced over the past few years by your investigations that this was a giant creature.
That it was a giant creature?
Yes, but I realize that it's, now I'm learning that it's really me that added that dimension.
Yeah.
So is this a model, or is this the actual?
This is a model. This is just a kind of idealized wax skeleton of what it is. And the pieces that are in the drawers are meant to represent real specimens, because you can see some of them are broken and some of them are really worn away. So I guess that does kind of define the size a little bit, yes, but you know, maybe there are smaller ones and maybe there are some that are really large. I just haven't found them yet.